this section we're going to talk about parallel lines and skew lines. Parallel lines are lines that are in the same plane that never intersect. So they run in the same direction, and for future reference, we'll need to know this, they have the same slope. So if I look at two pins, they're parallel as long as they don't touch. Now they're in the same plane here where the plane is like flat this way, or they could put them like this where they don't touch and they're in the same plane and the plane is going this direction. So as long as they line up, regardless of where I put them in space, if they're lining up, there is a plane that exists that has the two of them together. Okay? They're kind of like railroad tracks. But they can be railroad tracks like way out in space being weird. Like space railroad tracks. Skew lines are not in the same plane, but they don't intersect. So they're like parallel in the fact that they don't intersect, but they're not like parallel because they don't run in the same direction. So they can't be in the same plane. So if I look at these two pins and I put one like here and I put one way up here, even if I was talking about the two planes that are flat like my hands, there is a plane that exists that these two lines are in that goes up and down. So they can be in the same plane. A skew line is slightly turned. They'll never intersect, but there's no way for them to be in the same plane. There's not a plane that would exist that would cover, if you think about a piece of paper, right? I can't have a piece of paper that both of these pins will stick to the way they are. So skew lines don't run in the same direction like a train track. They're kind of turned from each other. So the best way to visualize it is on the surface of a box. Okay. If we look at the box, and let's say I look at this top front edge of the box, this edge, and then these two edges all run in the same directions, right? As I go around the box, those edges are all going in the same direction, so those are all parallel. This edge does not intersect this edge back here, right? They don't intersect, but they don't run in the same direction, so those would be skew. One is going up and down, and the other one's going side to side, but they're not in the same plane. So they don't intersect. This is basically kind of like a cheese wedge, sort of. It's a triangular prism is the official name, but it's kind of like a cheese wedge. So first thing, I forgot to go in and put the lines over all the segments, so I apologize for that. So we'll be fixing that as we go. Let's look at JP. Here's JP. Ooh, that's too skinny. JP. Okay. For lines that are parallel to JP, we're going to be looking for the lines that are going in the same direction and on the same plane. So we have a plane here, and then KQ. Okay, so LR and KQ. And you could have said RL and QK. Those orders doesn't matter, right? Okay, so that's parallel. And now we're going to look at KL. All right, so when we were looking for skew, we want lines that don't intersect but don't run in the same direction. JP is one of them. RP? Yeah. RQ won't. RQ is going to be parallel because see how they're on the same plane? RP does though, and so does QP. Right? Because QP will never intersect with LK, but it doesn't go in the same direction. It's not parallel. RP, same thing. It will never intersect with this, but it's not in the same direction. So in this instance, our one segment has 3 skew segments. So I have JP, RP, and QP. Okay. Now when we talk about parallel planes, we've got plane PQR, so that's this plane here. And so the plane parallel to it is the opposite side of the figure. Yeah, so plane LKJ or JKL or however, you know, the order doesn't matter. We're going to start with skew to BC. So first I need BC. And then I want the lines that won't intersect it but don't run the same direction. Which one? AE? Yeah. Yep. That's right. So you're going to get kind of like on the box, you're going to get L's on the opposite side of the box. So we get AE, EF, DH, and HG. Any questions on that at all? So just skew, when you're thinking about skew, just they never intersect, but they don't run in the same direction. When we talk about a segment parallel to EH, here's EH. So parallel is going to run in the same direction. So parallel are going to be all the ones that go up and down the same direction. So AD, BC, oh, see, these should also have lines on them, and FG. Now planes, remember we talked about how plane only has to have 3 letters to define it? And so if we're looking at this plane DCH, it's this whole bottom box even though we didn't list all the letters. So if you only have the 3 letters, that's okay. It's still the whole bottom of the box. So we could call it plane DCHG if you wanted to. It's the same thing. You just 3 letters is the minimum number to call a plane. You can call it by 4 letters if you want to. So if it's more comfortable for you to put down all 4 corners, go ahead and do that. So the plane that is parallel to the bottom of the box is the top of the box. So you could call it by all 4 letters, or you could call it by any 3 letters. Oops, I already did ABE. It might be FE. Or BEF. Okay, so I can use any combination of 3 letters. AEF. Did I use AEF yet? So I use any combination of 3 letters, or I can use all 4. Just as long as I'm getting the other side of the box, the top of the box. So just try these. Okay, on this particular answer, these are all the same plane. There's only one plane that's parallel. I just listed the different ways you could name it, but it's actually just one answer. So if you used any combination of letters that are shown here, then you got it right. Basically, as long as you knew that it was this side that's parallel, you're good. Okay. The segment's parallel to AB. AB runs here, so all of the parallels are the ones that run the same direction. We're good? Segments that intersect GH. Here's GH. These guys all hit GH. So you've got those 4. Oops. And you had segments skew to CD. So here's CD, oops, here's CD. And skew, don't intersect, but don't run the same direction. So you've got those two up there and these two back here. Any questions at all on any of those? I don't know if I put enough room on here, but okay, a transversal is a line that intersects two other lines. Okay, so in this instance, this line is my transversal because it intersects these two lines. And it creates two sets of 4 angles. Okay, so I have 4 angles here and 4 angles here. Okay. And these angles have relationships with each other. So you have interior angles. Interior angles are on the inside of the two lines that are being transversed. Oops. So this is the interior. Okay. And my interior angles are there for angle 4, angle 3, angle 5, and angle 6. So all of the angles that are on the inside between the two lines. Okay. The exterior is the part that's on the outside of the two lines that are being transversed. And so I have 4 exterior angles, and those are angle 1, angle 2, angle 7, and angle 8. Consecutive interior angles. Okay, consecutive means to come in order, right? These are also known as same side interior angles, depending on who you talk to. Okay. They're on the same side of the transversal and on the inside. So they're interior, meaning they're in the green, and then they're on the same side of the transversal. So angle 4 and angle 5 is one pair of consecutive interior angles, and then angle 3 and angle 6 is the other pair. You have 2 pair. And then you have something called alternate interior angles. So again, they're in the green part because they're on the interior, but they're on opposite sides of the transversal. So angle 4 and angle 6 make alternate interior pair, and then angle 3 and angle 5. And they kind of make an X. You see, like I can make an X between 3 and 5 and 4 and 6. So the alternates make an X. And then you have alternate exterior, so same idea, but they're on the yellow part. They're on the outside, but on opposite sides of the transversal. So angle 1 and angle 8 make a pair. Angle 1, angle 8, so opposite sides. And then angle 2 and angle 7 make a pair because they're on opposite sides. And then you have corresponding angles, and corresponding angles are kind of interesting. So let's say I were to draw a box. Does that show up? That doesn't show up. Hold on. Let's do it in... If I draw a box around these. Okay. Do you see how I have 4 kind of quadrants? 1, 2, 3, 4, 1, 2, 3, 4. They're the same 4 boxes. Corresponding angles are going to be in the same part. So you have angle 1 and angle 5. So see how they're both in the top left corner? And then you have angle 2 and angle 6 because they're both in the top right corner. Angle 4 and angle 7 are both in the bottom left corner. And then finally you have angle 3 and angle 8 because they're in the bottom right hand corner. Actually, let me pause that first. Same idea, but with color instead of numbers, because sometimes I think that's more helpful. What you have is you have 4 interior angles, those are these 4 here. And you have 4 exterior angles, those are the 4 that are out here. You have alternate interior angles, so these are pairs, these are angle pairs, they go together. You have the pink and purple, or sorry, pink and yellow, and then green and purple, or alternate interior. And then you have alternate exterior, you have orange and red, and blue and baby blue. So those are angle pairs. Consecutive are in the same side interior, so pink and green and yellow and purple go together. And then corresponding are in the same position, so pink and red are in the same like corner. And then you have blue and purple in the same position, green and baby blue in the same position, and yellow and orange are in the same position. We're going to classify the angle pair relationships. So we're just going to start with looking at them. Okay, here's our transversal. You need to identify your transversal first, because the transversal determines if you're alternate or not, right? Because you have to be on opposite sides of that to be an alternate anything. So here's my transversal. I have 1 and 5. They're on opposite sides, and then they're on the outside of the 2 lines. So it's alternate. The 1 and 5, but that would have been dark blue and baby blue. Do you see what I mean? Not the yellow. Okay, so then we'll come back and we'll look at 6 and 7. 6 and 7 are on the same side of the transversal and their interior. And so if you're on the same side and your interior, that makes you consecutive. So same side, inside, you're consecutive. Okay. Then we have 2 and 4. 2 and 4, one's on the outside and one's on the inside. But if you look, remember when I talked about, like, if we draw the kind of square around it, we have positions. 2 and 4 are in the same position, so they're corresponding. Yeah. Okay. 2 and 6, opposite sides of the transversal, interior. So alternate, interior. Oops, button. 3 and 7, same, yeah, same. Okay, then we have 5 and 7, corresponding. 4 and 8. They're on opposite sides of the transversal, and they're on the exterior, so they're alternate exterior. Nothing. They don't have a, there's no name for it. They don't have a relationship. Yeah, so 7 and 4 have no relationship because one's inside and one's outside, but they're not in the same position. So 7 and 5 are okay, but 7 and 4 have no relationship. Does that help? Yeah, they don't hang out. They don't have, they got nothing in common. And then 2 and 3 are on the same side on the interior, so they're consecutive. Considered a transversal. You want to identify the transversal for the angles you're talking about. Okay, so in this case, I'm just gonna first go through and identify the transversal just to show you how to do that, and then we'll figure out the relationship. So angle 1 and 3, we're here and here. So I have 3 lines, right? The one line that is intersecting the other 2 lines, that's the transversal. So in this case, the transversal is H, right there. If I look at 5 and 6, I have 1, 2, 3 lines. These are the 2 lines. The line that connects those 2 lines is the transversal. So in this case, the transversal is K. 2 and 6, I have 2 lines with a transversal. So in this case, the transversal is L. 3 and 5, I'm talking about these 2 lines with this line connecting them, so the transversal is J. And then 7 and 5, again, these 2 lines, so my transversal is K. Okay, so now that I know where the transversal is, that also lets me know which 2 lines I'm talking about for the interiors and exteriors. So here we said H was our transversal, so that makes J and L my 2 lines. And if I look at angle 1 and angle 3, so angle 1 and angle 3, they're outside the 2 lines on opposite sides of the transversal, so that makes them alternate exterior. And you can abbreviate if you want to. If we look at 5 and 6 again, they're inside on the same side, so consecutive. Two and 6. Here's my 2 lines. They're in the same position. You know, if I were to draw the boxes around, 2 and 6 are in the same position, corresponding. Excuse me. 3 and 5, we're outside, so we're alternate exterior again. And then finally, I had 7 and 5. So 7 and 5. I'm in the same position in the X's, so corresponding. Okay. So like here, when we look at 4 and 10, we look at the 3 lines. So to figure this out, you look at the 3 lines that are being touched. So 4 is touching this line, and 10 is touching this line and that line. So that makes G the transversal because it's the one connecting the 2. So yeah, 4 and 10 are going to be alternate interior. And the transversal on this is G. Which one? 17 you said? Okay, for 17 is 7 and 3. So I'm looking at these angles here. Yeah, so these are my 2 lines. J is my transversal, and 7 and 3 are corresponding. And the transversal is J.